In the previous video, we learned about how to make a frequency distribution of the categorical data or variable. Now, we'll be learning about how to make a frequency distribution of numerical variable which includes interval or ratio data. If the data is numerical, we need to determine the class interval. So generally, the number of classes for a frequency distribution table varies from 5 to 20, depending primarily on the number of observations in the dataset. It is preferable to have more classes as the size of the dataset increases. So the decision about the number of classes depends on the method used by the researcher. So let's have here the rule 1. To determine the number of classes is to use the smallest positive integer k such that 2 is the power of k greater than 11 or greater than n, where n is the total number of observation. Using the formula 2-1 in my reference, we can obtain the ideal class interval. So there the suggested class interval would be range or HB minus LB divided by k or the number of classes. Okay, where HB is the highest value in a dataset, K is the number of classes, LV is the lowest value in a dataset, and I is the suggested class interval. And rule 2, another way to determine the classes or class interval, we can apply the formula 2-2 in my reference. And rule number 3, another guidelines to determine the class interval is to have an ideal number of classes, then apply the formula 2-3 in my reference. But for us to have a uniform answer, we will use the rule number 1. Okay, take note, we will just use the rule number 1 for us to have a uniform answer. So let's consider this one as our example. The data is a group and our goal is to make this data into group frequency to group data. Okay? So suppose a researcher wishes to do a study on the monthly salary of a call center agents of selected business process outsourcing or the BPO companies. The research first would have to collect the data by asking each call center agents about their monthly salary. The data collected in original form is called raw data. In this case, the data are 18,800 pesos or 18.80 will be read as 18,800 pesos because it is in thousand, which is multiplied by that quantity by 1,000. Then 20,000 pesos, 20,250 pesos, 18,400 pesos, 18,700 pesos, that until the last data there, 17,400 pesos. Okay? Then we are asked to construct this following: range, interval, class limits, class boundaries, relative frequency, percentage, cumulative frequency, and midpoint. So we will use rule number 1 for this as we agreed. As our agreement, now we'll use rule number 1 for us to have a uniform answer. Solution, step 1. Arrange the raw data in ascending or descending order. In our case, we arrange the data in ascending order. Okay, we first write the smallest salary among the call center agents. We have there the 14,100 pesos or 14.10 until to our last or the highest salary with 33,700 pesos or 33.70. Then, step 2, determine the classes. Find the highest and lowest value. We know that our highest value is 33.70 and the lowest value is 14.10. And to get the range, we need to subtract. Highest value minus lowest value will give us 19.60. And that is now our range. So to determine the number of classes, Since n equals 80, to satisfy the formula rule number 1, 2 raised to the power of k greater than n, we need to find a number k which will lead us to a quantity greater than or equal to n. N is closer to n. So let's try to let k equal 6. Then this will give us 2 raised to the power of 6 equals 64. But 64 is lesser than n equals 60. Right? It does not satisfy to our given formula, so meaning there is a need to find another number. So we'll try. Next to 6 is 7. So 2 raised to the power of 7 is equals to 124. And 124 is greater than n equals 80. So thus k equals 7 is the best number of classes. So now we already have the value of k. We can now compute our interval. The class interval is the range divided by k, or HB minus LV divided by k, and we know that our range is only 19.60 pound above. Then divided by our k, and that will give us 2.80 or approximately 3. We'll just round it off, no? To approximately 3. And that is now our I, or class interval. Then set the individual class limits. We need to add the interval or weight to the lowest score taken as the starting point to obtain the lower limit of the next class. Then keep adding until we reach the 7 classes as reflected. So our lowest salary is 14,100. We can just round it up to into whole number, 14.10 to 14. And we have to skip counting by 3 since our class interval is 3. So 14, skip counting by 3, 17, 20, 23, 26, 27, 32, and that's it. We end up until 32 since this is only the 7th number of our class. And then these numbers are called the lower limit. And to obtain the upper limit, we need to subtract 1 unit to the lower limit of the second class. The lower limit of the second class is 17. We have to subtract that 1 by 1, and that will give us 16. Then 16, skip counting by 3. That is 16, 19, 22, 25, 28, 31, and 34. And that will give us these class limits. There, the pairing. Okay, 14 to 16, 17 to 19, and so on. Or simply, you can just always remember that our lower class limit will give us these numbers. Okay, skip counting by 3, 14, 17, until 32. And of course, the upper limit, since we need to subtract 1 from the second lower limit, which is 17, subtract 1, that will give us 16. And 16 will be the starting point of your upper class limit. So upper class limit will have 16, 19, 22, 25, 28, 31, and 34. And that's our sets of class limits with 7 intervals. No? So then set the class boundaries in each class. To obtain the class boundaries, we need to subtract 0.5 from each lower class limit and add 0.5 to each upper class limit. Okay, from 14 to 16 will give us 14 minus 0.5, 13.5, and 16 plus 0.5 will give us 16.5. So therefore, the class boundaries corresponding to that class limit will give us 13.5 to 16.5. And follow the same rules until we reach to 32 to 34 on the last row, and that will give us 31.5 to 34.5. And these are the set of our class boundaries. Then step 3, you tally the row data. So under 13,500 to 16,000.
500, there are 4 call center agents who have this range of salaries. Then for 16,500 to 19,500, we have 9 call center agents ranging their salaries from 16,500 to 19,500. Until we reach the last part, 31,000, the highest salary, 31,500 to 34,500. There are only 3 call center agents who have this range of salary, which is also the highest salary in our data. Then step 4, convert the tallied data into numerical frequencies. So then that will give us in column 4, that's the representation of our tallied data. And then now let's proceed to step 5, determine the relative frequency. It can be found by dividing each frequency by the total frequency. So meaning if we had 80 call center agents who participate in this research, then for frequency of 4, we need to divide it 1 by 80, and that is already the relative frequency. So if the solution is found in the column 4, so 4 divided by 80, 0.05. 9 divided by 80, 0.11. 16 divided by 80, 0.20. That until 3 divided by 80, and that will give us 0.04. If you add the relative frequency, and that is equivalent to 1. Okay? So to check your answer, if your answer is correct, get the sum of the relative frequency, and that must be equal to 1. Right? So now let's proceed to step 6 to determine the percentage. Simply the percentage is just you need to multiply the relative frequency times percentage times 100 will give you the percentage. Okay? Again, multiplying 100% in each relative frequency. We know that 4 divided by 80 is the relative frequency earlier in step 5. So we get this one as 0.05 times 100, and that will give us 5%. And there, earlier we get this 0.11 times 100, and that is 11%. And then 0.20 times 100, that is 20%. That until 0.04 times 100, that is 4%. A total of 100%. So that's it on how to find the percentage. You just need to multiply the relative frequency result times 100. Automatic, that is the frequency. Then step 7, determine the cumulative frequency. So the cumulative frequency can be found by adding the frequency in each class to the total frequencies of the classes preceding the class. So you have there the class limits frequency, and the third column is the cumulative frequency. How did we get the cumulative frequency? First, in the first row, just copy 4. In second row, you need to add 4 plus 9, 13, there. Then on the third row, you need to add these 3 quantities, 4 plus 9 plus 16 equals 29. On the fourth row, you need to add 4 quantities, 4 plus 9 plus 16 plus 23 equals 52. On the fifth row, you need to add 5 quantities, 4 plus 9 plus 16 plus 23 plus 17 equals 69. And the sixth row, you need to add the 6 quantities, and the seventh row, you need to add the 7 quantities, and that will give you 80, which is also the total frequency. And that's how we give the cumulative frequency of each given frequency of our data. Now let's proceed to step 8, the midpoints of the class. So meaning this is the middle of the class limits. How to obtain? Just refer to the class limits, column 1. 14 plus 16 equals 32, equals 30, divided by 2 equals 15. Okay? 17 plus 19, then divided by 2 equals 18. Then 20 plus 22 divided by 2 equals 21. And 23 plus 25 divided by 2 equals 24. Until on the last row, 32 plus 34 divided by 2 equals 33. And these are the these are our class midpoints of the given class limits or obtained class limit. Okay? And in step 9, the complete presentation of the frequency distribution table. You have there the column 1, the class limits, column 2, the class boundaries, column 3, the frequency, column 4, the relative frequency, column 5, percentage, column 6, cumulative frequency, and column 7, midpoints. And you have there also, in the last row, we add I equals 3, or the interval equals 3, and the total frequency of 80, and total relative frequency must be always equals to 1, and the percentage must be always, of course, 100%.